Today on the channel we're going to diagnose this VIC20. When powered on it gives us nothing but a black screen, and seeing as I don't know that much about VIC20s, we're going to use all the tools available to us. Oi. So this is our very yellowed and very trashed VIC20. It's obviously missing the badge and a key. Looking inside through the expansion port, I can see what looks like maybe a spider egg or something in there. So yeah, pretty nasty stuff. This one looks to have had a hard life. It does have the newer style power connector. The original ones had a 2-prong 9-volt AC connector. The later cost-reduced ones have a connector that's the same as the Commodore 64. So it has 9 volts AC and 5 volts DC, and thankfully I've got plenty of Commodore 64 power supplies. So we can plug that in there. The video output is a little bit different on a VIC20. I'm actually using a cable that I made for the Atari 8-bit lines because they share the same composite and audio outputs as the VIC20. The only difference is the Atari has Luma and Chroma output, whereas the VIC20 doesn't by default. So one of these pins on this S-Video connector, which is normally wired up to the Luma in the Atari, is going to have 6 volts on it. So whatever I do, I have to make sure not to try and plug in the S-Video connector, but that shouldn't be too difficult. So let's plug this in. I'll power it on, and that is what we get, a black screen. I do also have Sven Petersen's Hyper Expander cartridge, so this also doubles as either a RAM expansion or a ROM expansion or ROM cart. So I've got this set up for the VIC20 dead test, and we still get a black screen. So this isn't getting us anywhere at the moment. It's time to open this thing up and have a look at what's going on the inside. Alright, well, it doesn't look too bad at first glance. Let's remove this keyboard connector and the power connector. And yeah, so far, not as scary as I thought. In fact, it's kind of clean. It's a very different look from, yeah, looking through there, which, look at that thing. Ugh. But on the inside, pretty clean. Just so I'm not fighting with this cardboard foil shield, I'm just going to pull the whole board out just so I can get rid of this thing. There's always one. Alright, that should do it. Nope. While we're here, let's look at the underside of the board. I do not see any evidence of work being done. There are a couple of hand soldered joints over here, but I don't know. That might have been a factory thing. Obviously, these two connectors always get hand soldered at the factory by the looks of it, even on the Commodore 64. So yeah, nothing too major going on there. All right, let's check out some voltages just to make sure we're actually getting the right power. So the first thing you always want to do is check your supply voltages. We know that most of this machine runs off 5 volts DC. I believe the AC only powers maybe the cassette port, and I'm pretty sure it also heads over to the user port. I think it's along this big cable here that looks like a bodge. I don't really know what happened there. Maybe they forgot to include the traces for the AC across the board, and somebody went, I don't really want to redesign the board. Let's just put a big ass bodge wire running over there. Who knows? But yeah, everything pretty much runs off 5 volts DC. So let's check that out. So all we need to do is find a place where we're sure we're going to have ground and 5 volts. Usually it's easy just to look up one of the major ICs like the 6502 here, and if we look at the schematics for the VIC20, we can see that pin 1 and pin 21 are both ground or VSS, and pin 8 is VCC. This is pin 1 next to the notch here, and pin 21 is going to be this pin down here. So we can use that for ground, or we can use pin 1 for ground. And then pin 8 is going to be, well, 7 pins down from this. So powering the machine on, we do see 4.93 volts. Now it is a little bit awkward to hold the probes like this, so what I prefer to do usually is find a convenient ground location. So if we put our multimeter to continuity, one probe on ground, one probe on just the cartridge shield here, and that is connected to ground. Usually a lot of these shields are going to be ground. Also the outside of the boards are generally ground as well. So it's much easier just to clip something onto there, like so. And now we have one hand free just to go around the board and check for voltages. So yes, 4.95 volts, I'm sure that's fine. I'd be worried if it was probably under 4.8 or 4.7. And if it was over, say, 5.2, 5.3, that's probably a bad sign. But yeah, 4.9, perfectly fine. We can also check over here on the user port. I believe that this one is ground, and this one on the other side of the notch should also have 5 volts. So yeah, 4.93. I'd say the 5 volts is making its way around the board just fine. And of course we did have what looks like a black screen. Now on certain displays they don't offer a blue screen or a no signal indication, so sometimes it's best to check to make sure you actually are on the right input on your display or whatever, because if you go from a black screen to a black screen, how do you know that this is what's producing the black screen and it's not just the display's default no signal behavior? Of course, to double check that, we can always bring out the oscilloscope. This one here is a 2-channel portable scope, very similar to the one that Adrian from Adrian's Digital Basement showed a few months back. He's been testing out a lot of budget scopes lately, and he tested one that was very similar to this, but a yellow color, and it was only single channel. So after seeing that video, I decided to see if there was a dual channel one, and there is. So that's what I picked up. This was about, I think it was $120 Australian, so $80, $90 US. But I've been pretty happy with it, so I figured why not use it in this video and put it through its paces. So again, I'm just going to hook the ground connection up to this cartridge cover, and let me just turn off channel 2 on this thing. And we're set to AC coupling, so the video signal, when we eventually find it, should be sitting in the center of this display. Is that it? Let's just auto that. That does. I'm still working out the whole button arrangement on this little scope. Much more used to having dials to adjust everything. So yes, that does actually look like our video signal. So we can see every so often there's 3 little dips there, and then there's what looks like a bunch of noise. That's the color burst signal. And then it's basically flat. And you can imagine that flatness as black. So we're getting a black screen. So it tells us that this machine is definitely putting out a video signal. The VIC is likely to be working, at least it's working enough to put out a video signal, but all we're getting is a black screen. While we're playing with the scope, let's just check the clock signals, because that's usually the next thing you want to look at. And looking back again at the 6502, where are we? Here we go, pin 37, I think it says, is our clock going into the CPU. So if that's 40, 39, 38, 37, let's just auto set that. And yes, that looks like a 1.11 megahertz clock. I assume that's correct for the VIC20. I think it does run just over 1 megahertz, so that looks pretty good. And pin 3 of the CPU should have the clock output, which should be pretty much the same, which it is. Let's just double check our reset line, which is pin 40. So normally it should be low and then go high once the CPU comes out of reset. And at the moment it looks low, but that's because I'm actually in AC coupling mode. So when you have the scope set in AC coupling mode, it's going to remove any DC offset. So it'll center everything around the middle line. But if you're looking for just a static voltage, it's best to have DC coupling on. Let's do another auto set to bring that back in. So yes, we can see that it is sitting at 4.86 volts or thereabouts. So the CPU is coming out of reset. If I power the machine off, it drops to 0, and powering the machine on, it sits low for a little bit and then goes high. So CPU is coming out of reset. In theory, the machine should now be running, but we're not seeing anything on the video output. Let's have a look at some of the data and address signals from the CPU. So looking at the schematic, from pin 9 to pin 25 is our 16-bit address bus. So let's have a look at some of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. The auto mode is actually pretty good on this scope. I'm impressed. So yes, these signals all look pretty normal. I might just zoom that out a little bit more. Yeah, I'm not seeing any issues with those so far. Everything is between 0 and 5 volts, and there's no weird transitions going on. There is a bit of a lump on some of the signals. I think that is normal as well. So yeah, the address lines all look pretty healthy. It's just a bad connection on that one. 21 is obviously ground. 22 is also the same, all hovering around 3.6 volts peak to peak. And this looks very strange. What were we up to? It's 21, 22, 23, 24. Ah, okay. So that's pin 25, so that's our last address line. And then pin 26 is where data bus is. So 26 to 33 is the data bus, and yes, that does not look right. So we've got these little lumps every so often that only peak up to about maybe 1 volt or so. That certainly doesn't look correct. So that's address line 6. This would be address line 5, which looks better. It still looks a bit odd though. Address line 4 doesn't look right. 3 doesn't look right. 2 doesn't look right. 1 doesn't look right. And 0 doesn't look right. And then that's whatever that is. So what we're seeing is the whole data bus from the CPU looks incorrect. Now that doesn't necessarily indicate that the fault is with the CPU. It could be something interfacing with that. Let's just have a look with the thermal cam, see if that gives us any clues. So normally if there is a chip that's shorted or something like that, it's going to produce a lot of heat. The thermal cam doesn't line up very well, but over here are our 6522 VIA chips, so they control input and output. They look pretty normal, 44 degrees, probably standard. And moving along the board, there's some RAM and some logic over here. That all looks pretty normal. This thing up here is probably the hottest on the board, and that is the VIC chip. It's probably normal for the VIC to be hotter than everything else, considering the amount of work that it's doing video and audio, along with a bunch of other things. Some of the ROM chips, I don't know which ones these are, but one of them is the basic ROM, one of them is like the kernel ROM and character ROM or something. These look a little bit warm, but still, again, nothing too crazy. And yeah, finally the CPU. Everything looks to be at about 49 degrees Celsius, so nothing really standing out as getting toasty hot. So thermal cam may not help us today. So let's just see if we can follow these signals. So they're all labeled CD0 to CD7. So it looks like they go straight across here to UF8, which is a 74LS245. That's this guy on the board here. And they also go up to pages 2 and 3, I believe this is indicating. So we're on page 1. Let's see if we can find CD0 and CD7 on 2 and 3. There's BD0 and BD7. That's still the address bus, but it's probably after, maybe after this 245 logic. So although it's the same bus, it's not necessarily the exact thing that we want to look at right now. We want to focus on anything that says CD. And I'm not finding it here. Ah, there they are. CD 0 to 7. That's just going to the expansion port. Although that might be handy. So pin 2 of the expansion port, which is this one back here, has our data bus signal. I'm just going to hook the second channel probe onto that. So that way we've just got a constant view of what's happening on the data bus, and I've got a spare probe handy and a spare hand to probe other things. So the green line on the scope is now CD0, which is our address bus or data bit 0. So you can see here that it says 1,3, so it's indicating that this CD0 to 7 was on page 1, which was the CPU that we saw, and it's also on page 3 somewhere. So if we look on page 3, here we go. CD0 to CD7, and yeah, page 1 and 2, we already looked at them. So that comes across here, goes up to, whoa, this, what is this? UE11, which is a 2364, so that's got to be one of the ROM chips. UE11 is this one here. Doesn't actually indicate what UE11 does, so I'm kind of interested. I do also have, I think this is the schematic for the original 9-volt AC version. In fact, yes it is. So yeah, the original 9-volt AC version obviously has a bridge rectifier and a bunch of voltage regulation going on inside, but this schematic is a little bit more detailed. Huh. But it still doesn't tell me what either of these ROM ICs are. Okay. There we go. UE11 is the basic ROM. All right, let's have a look at the signals there. They should look the same as what we saw on the CPU, but we'll just double check. So pins 9 to 17 should be our data bus signals. So if that's pin 1, so as you can see, that looks exactly the same as the other channel. I might just adjust these signals just so they're not overlapping as much. So yeah, these are all our data bus signals. That's ground. And not surprisingly, they look exactly the same as they did on the CPU. These are directly connected to the same pins. So let's go back and have a look at the other place these signals went to, which was this 74LS245. Now this looks like some kind of buffer chip. So we've got data signals on this side and data signals on this side. 74LS245 is an octal bus transceiver. Okay, so it's taking all the data signals from one side of the board, so all of this stuff and the data signals from this stuff, and basically interfacing them. So it'll either select data signals from this area of the board or data signals from this area of the board and allow them basically to talk to each other. It also buffers everything, so you get better signal integrity, cleaner transitions from 0 to 1. So in theory, looking back at the schematics, if we look at CD0, which is pin 16, that's what the other channel's hooked up to at the moment. So that's CD0. If we look on the other side at BD0, we should see something very similar. 2, 3, 4. So that's pin 4 on the other side. It does look similar. Looks like there's a lot more noise on the other side, so BD0 looks quite noisy. And let's see, where does that start from? It goes from pin 2 to 9, so pretty much everything on this side should also look a bit screwy. And honestly, it doesn't look as bad on this side of the transceiver. In fact, that looks pretty normal. What's that? Pin 5, BD5, which was the same as CD5. Data bit 5 was the only one that looked somewhat normal. Pin 6. Pin 6 is data bit 1, so that's going to be that thing. Yeah, So both sides of this 245 look screwy. Let's just double check the direction pin. So this should be flipping back and forth. So yes, it's enabling either data to go from this side to that side or that side to the other side. So that looks about right. It seems to be going back and forth. And the other pin we want to check is output enable, which is pin 19. And yes, that also seems to be flipping back and forth. So the 245 seems to be functioning correctly, but that doesn't mean that it's not at fault. It could be that, could be the CPU, could be this ROM, could even be something on this side of the board that's messing up this side of the board. What we're going to do is isolate these two portions. And the way to do that is with the output enable of the 245. So looking at the datasheet for the 245, if we pull output enable high, that'll isolate both of the data buses. So we're going to isolate these two parts of the board. That way we should be able to see what's going on with this part of the board and see if the fault remains there, or if the fault goes over to this part of the board and the CPU and everything end up looking fine. So what I'm going to do is snip pin 19 and just connect it directly to 5 volts. That'll isolate both of these data buses and hopefully we'll be able to see something different. So I'm just going to carefully come in here, snip that. I can always come back and put a blob of solder on there to reconnect it. Just make sure we have actually severed that connection. Yep. And what's kind of handy is pin 20, which is right next to it, has 5 volts on it. So we just need to connect those two pins. Just going to use that to grab pin 20 and that to grab the remains of pin 19. And they are definitely disconnected. So we now have pin 19 just going to 5 volts, not connected anywhere else on the board because we don't want to send 5 volts to the other IC that it was connected to, pin 9 of UD9. So now these two buses should be isolated, or these two sides of the data bus. Let's power it on. We should still get a black screen, which we do. And we can also see that the second channel still looks wonky. So looks like the data bus is messed up on this side. Let's double check that against the other side. So now looking at all these BD signals, which are the data bits from this side of the board, everything looks pretty silent, and the things that do have something going on actually look fairly peaky. That's not a big surprise because the CPU and ROMs are all on this side. So if we disconnect this side from that side, there's not going to be much activity going on over here. So CD and BD look very different from each other. Obviously all the CD stuff has the CPU and the ROM ICs, so that's where most of our activity is going to come from anyway. And the stuff on the BD side doesn't really have much going on. It can't really drive the data bus without having the CPU and the ROMs there, at least from what I understand. So I think if we had an issue over this side of the board, after we isolated these two sides, everything over here should now look normal, but it doesn't. So I think everything over here is okay, and the issue is just between probably either the CPU or this basic ROM. I'm going to put my bets on the basic ROM being bad. I guess there is a slight chance that it could be this 245, but yeah, I somehow doubt it. So I'm going to reconnect this leg before I forget. So this should now be connected back to pin 9 of UD9. Yes, it is. Cool. All right. So let's take another look at the ROM IC, and I want to look at pin 20, which is the chip select. So if that's 24 pin ROM, so that's 24, 23, 22, 21, 20. And that doesn't look right. It is stuck high. Let's have a look at pin 20 on this. I think this is the kernel ROM. That's pin 20 on the kernel ROM. So you can see that the kernel is being selected every so often. That's what I'd expect to see on the basic ROM as well, not just having it stuck high. So where does that signal come from? Looks like block 6 on pages 1 and 2. So block 6 on page 2 shows us that it's connected to pin 9 of UC5. This is UC5. That's pin 9. So yep, that's what looks screwy. And it's a 74 LS 138. Looks like the 138 is a 3-line to 8-line decoder. So if all we're getting is a high signal on output pin 6, it means that if we look at output, so everything's high except for this combination. So what we want to see is if A goes low, we should also get a low on the output. A is pin 1, so if we're seeing low pulses here, which we are, then we should also see low pulses on the output. Pin 9, which we're not. Let's move channel 2 over to here. So yes, that's stuck high. There's pulses there. Let's just check the other conditions. So G2A and G2B need to be low. It's pins 4 and 5. That's low, and that's low. And then G1, C, and B all need to be high. G1 actually has activity on it, so that means that this output should also be flipping with that, I guess. And B and C are pins 2 and 3. And they also have activity on them. So with all of those inputs doing different things, we'd expect the output to also follow that. And what we're seeing is the output is just stuck high. So I think this 74 LS138 is our culprit IC. And to be honest, I totally wasn't expecting that. I was thinking CPU, probably this basic ROM or this 245. Didn't think about any of these ICs up here when I first started. So yeah, if I was just going ahead and desoldering things and socketing them, the CPU, this and this would already have come out by now, and I'd probably still be chasing a problem. It may not be just this 138. It certainly looks like an issue when I'm looking at it on the scope, but maybe I'm interpreting something wrong, but I'm definitely going to pop this out and we're going to see if it makes any difference. Alrighty, let's get this guy out of here. So it's going to be this right here. Just going to add some fresh solder while I wait for the desoldering gun to warm up. And as I add the fresh solder, I like to just give the pins a little bit of a jiggle around, just to make sure they fully loosen up. Those pins are not moving, although it looks like from the top side a lot of these are freed up, at least on this side. Just one pin that's bent over. There it goes. So there was one pin, this guy here, that was fighting with me. It's slightly shorter than the rest. It's like it's been cut off somehow shorter than all the others, and that was holding it in there. So let's just put this in the Mini Pro, see if it actually tests as good or bad. Go into our logic test, and it is a 74 138. Get out of the way. Test. Everything tests normal. So if everything tests normal with this, then it is actually the basic ROM that's at fault, and it's holding the chip select high all the time. Does that sound right? Well, while we've still got all the tools heated up, may as well pull out the basic ROM. is this here. Beautiful. All right, basic ROM. So, because this is a 2364 and the Mini Pro does not support 2364 ICs, I have a little adapter here. I actually showed this in a previous video quite a while back, so I'll put a link up there, or up there. We're going to put this in our little adapter. This takes 2364 and pretty much converts it to a 2764. So in here, we're going to look for a 27C64. Doesn't really matter which manufacturer it is. We just need to turn off the check ID and the pin detect. And we should be able to read this back. And we have read back nothing. Nothing at all. So a blank ROM? Just to make sure my adapter's working, I'm just going to test it out with this. I think this is a Commodore 64 kernel ROM. So if we hit read, yep, there we go. That looks very kernel ROM-alike. Yeah. So the adapter is definitely working. This basic ROM from the VIC20 is not. There are a couple of random 20 bits here, but, or 20 bytes? No, 20 nibbles. But yeah, big old mess. In fact, didn't see that last time, so it might be just putting out different crap every time I go to read it. Yeah, it's bad for sure. Well, I guess it was either going to be one or the other. I just picked the wrong one to begin with. Alright, so with an actual 27C64, we're going to program a VIC20 basic ROM. Let's just do a blank check. ID error. Well, these chips are from AliExpress. Even though they do say ST and the correct part number, they're probably not legit. So it's likely to still be a 27C64. It's probably just a slower variation or something. I don't think it's going to matter for the VIC20. Well, need to leave that in there because we need to program it. All right, let's have a look. Zimmers should have what we need. Bo's got a good collection here, so we need basic 901486-01. That's what this chip says. Let's grab that. It is the first and only version. Well, at least we don't have to choose from anything. All right, well, that's what this IC should have looked like. So yeah, definitely bad. Let's program our 27C64. Programming succeeded, so that is good to go. All we need to do now is make a little adapter. So this one comes from restorestore.de, but you can find the PCBs, I think, on PCBWay's shared project page. This is not a sponsored video this time, by the way, but yeah, you can find it there if you're looking for these. So it'll take a 2764 and adapt that to a 2364 footprint, which is what the VIC20 obviously has. So we're going to need a 28 pin socket, and I probably should get a socket for this guy while I'm in here. And normally I'd put a 24 pin socket on the board, but seeing as we're putting an adapter on this anyway, so it's going to have a socket on top of that, may as well just put regular pin headers in the board itself. So I've got 2 rows of 12 round pin headers, so we'll put those into the board first, and then a 28 pin socket sits on the top. I'm just going to use the VIC20 board to keep everything in alignment. Cool, that all looks pretty straight. Right, and with those soldered into the board, we can now put our socket over the top. Okay, everything looks good there. Let's get it back in the board. Alright, and let's not forget the socket for the logic IC. Alright, let's get our replacement ROM in and put back the working logic. And with any luck, we'll have a working machine. Right, before we even connect the video output, let's just see what it looks like on the scope. I guess the first thing to look at is pin 9 over this guy. Let's power on. And there... no. Hang on. There's our... Alright, so we saw pulses during the... what? Let's have a look at one of the data lines. So this is data line 0. And there's activity, normal looking activity, even before the CPU comes out of reset. Right, let's go back a little bit. So looking at the CPU, pins 26 to 33 were our data lines that looked screwy. 1, 2, 3, 4, 5, 26. That looks pretty good. 27 looks good. 28 looks good. 29 looks good. Looks good. That looks good. That looks good. And that looks good. So everything looks pretty normal now. I wonder if there's a video signal. I guess we should actually, just for shits and giggles. Black screen. Oh. It does work. What? So, hang on. Right, so it turns out the basic ROM only gets selected during the power-up sequence. So that's why I wasn't seeing anything on the chip select line for it, because it's not addressing it all the time. Wish I'd have known that before, but I guess that's being unfamiliar with the VIC20 and how it works. So yeah, that probably would have saved me pulling out or suspecting that logic IC, and I probably would have gone straight for the basic ROM. But oh well, it appears to work. So what I should have done was powered on and off the machine a few times to check some of the behavior, but what can you do? We got there in the end. Now, I do have to wonder what the dead test cartridge now looks like. In theory, this should just work. And basic character and kernel ROMs turn green. I assume that means they are good. So, looks like this machine is back up and running. And we do have audio output. I'll just mute that. While I've still got the scope here though, we might just check out the composite video output to see if it's actually at the expected levels. Alright, so the overall voltage that we're getting on our video signal is 832 millivolts. We want that to be closer to 1 volt. So the VIC20 does have this trim pot here that we can adjust in order to bring that up a little bit more. And that's lowering it. This is looking a bit more like it. That's pretty much spot on. So yes, that is better. It'll improve the video output just slightly. I mean, the VIC20 especially, I think the cost reduced version has some pretty bad composite video output. I don't plan on looking into S-video outputs today. I know there are mods out there for it, but I'm going to stick with the composite for now. I'm just happy that it's working. So, after all that, we only had a bad basic ROM and a chip select line that led me astray. The case obviously needs a lot of work, as does the top cover. I think I may actually have that key around here somewhere, so I just need to get a new stem for it. And yeah, a new badge wouldn't go astray either. There's a bit of damage up here to the case. But I'm just happy that the machine currently works, so the cleanup can happen later. As for now, I think that's going to be it for this one. So as always, a massive thanks to the people that support the channel on Patreon, and if you want to do the same and get ad-free early access, links are down below. But yeah, thank you all for watching, and don't forget to leave a comment, let me know what you thought, and be sure to like, subscribe, and all that stuff. I will see you in the next one. Bye. I didn't hit record on that. Fuck.